what happens when you put when you put resistors in a row. So for example, I have a battery here. Here's my battery element. And I put a resistor like this, resistor like that, a resistor like that. Okay, so these are R1, R2, R3, and this will be delta V battery. Okay. Let's go ahead and try and analyze this and think about, can we come up with a rule about what the battery is effectively seeing when he sees resistors that are connected end to end. Now, to think about, if you're the battery, you're pushing current based on how hard it is to push the current. Okay, you can't necessarily see that there are three resistors. You see some effective resistance. Okay, so to try and understand this, let's take a look at these resistors and do our loop roll. I'm going to start in this corner here, and I'm going to go around clockwise. Seems reasonable since that's positive and negative, and so I'll assume that's the direction of the current all the way down. And there is only one loop, so no junctions, which means that current must be the same through all resistors. So as I do my loop rule, starting here, I go clockwise, so I first go across the battery, get a positive delta VB because I'm going from negative to positive, and then I'm going in the direction of the current, so I lose an amount of voltage across resistor 1 of IR1. I lose an amount of voltage across R2 of IR2, and I lose again IR3, getting back to where I started, so that equals 0. Well, since I is the same for these, delta VB minus I R1 plus R2 plus R3 equals 0. And I could call that an effective resistance, delta VB minus I R equivalent. EQ would stand for equivalent, okay? So the battery sees this equivalent resistance, which ends up just being the sum of the others. REQ equals R1 plus R2 plus R3 plus, if there were more in series, you just add them up. And we call this the series equivalence, resistors in series, because they're one after the other. And they're in series for the same reasons as we saw earlier, capacitors are in series. Is whatever current's flowing through this one must flow through this one. There are no junctions. There are no junctions between those two resistors. Okay, so if you can go from the end of one resistor to the end of another resistor without anything else in between, including a junction, then those are in series, and we get this rule. Okay, that's series resistance.